Kubernetes is a powerful container orchestration platform, but its complexity can lead to misconfigurations that compromise security, performance, and reliability. Following is a detailed view of common Kubernetes cluster setup misconfigurations, their implications, and best practices to avoid them. 1. Insecure API server access. Misconfiguration, exposing the Kubernetes API server to the public internet without proper authentication or authorization. Implications: unauthorized access to the cluster, potential data breaches or resource hijacking. Best practices: restrict API server access to trusted IP ranges. Use strong authentication mechanisms, example, client certificates, OIDC. Enable role-based access control to limit user permissions. 2. Weak or missing role-based access control policies. Misconfiguration, overly permissive roles or cluster roles, or failing to enable role-based access control entirely. Implications: users or services may have excessive permissions, leading to privilege escalation. Increased risk of accidental or malicious changes to the cluster. Best practices: follow the principle of least privilege. Regularly audit role-based access control policies and remove unused roles. Use tools like KubiiWALL to verify permissions. 3. Insecure network policies. Misconfiguration, not implementing network policies to restrict pod-to-pod communication. Implications: unrestricted communication between pods can lead to lateral movement in case of a breach. Best practices: use network policies to enforce segmentation. Deny all traffic by default and allow only necessary communication. Regularly review and update policies as workloads change. 4th, improper secret management misconfiguration, storing sensitive data, example, passwords, API keys, in plain text, config maps, or environment variables. Implications: exposure of sensitive data to unauthorized users or attackers. Best practices: use Kubernetes secrets to store sensitive data. Encrypt secrets at rest using encryption providers. Avoid logging or printing sensitive data. 5. Lack of resource limits and requests. Misconfiguration, not defining resource requests and limits for containers. Implications: resource contention, leading to performance degradation or cluster instability. Potential for a single pod to consume all available resources, noisy neighbor problem. Best practices: define resource requests and limits for CPU and memory. Use horizontal pod autoscaler to scale workloads based on resource usage, monitor resource usage, and adjust limits as needed. 6. Unrestricted access to etcd misconfiguration, exposing the etcd database, Kubernetes key value store, without authentication or encryption. Implications: compromise of etcd can lead to complete cluster takeover. Best practices: restrict access to etcd to only the API server. Enable mutual TLS for etcd communication. Regularly backup etcd data. 7. Insecure container images. Misconfiguration, using untrusted or outdated container images. Implications: vulnerabilities in images can be exploited to compromise the cluster. Best practices: use images from trusted sources, example, official repositories. Scan images for vulnerabilities using tools like Trivy or Claire. Regularly update images to patch known vulnerabilities. 8. Missing pod security policies or pod security standards. Misconfiguration, not enforcing security policies for pods. Implications: pods may run with excessive privileges, increasing the attack surface. Best practices: use pod security policies or pod security standards to restrict pod capabilities. Disallow privileged containers and enforce read-only root file systems. Replace PSP with admission controllers, example, OPA Gatekeeper, in newer Kubernetes versions. 9. Inadequate logging and monitoring. Misconfiguration, not enabling or configuring logging and monitoring for the cluster. Implications: difficulty in detecting and responding to security incidents or performance issues. Best practices: enable audit logging for the API server. Use monitoring tools like Prometheus and Grafana. Set up alerts for suspicious activities or resource usage spikes. 10. Improper node configuration misconfiguration. Not securing worker nodes or allowing unnecessary access. Implications: compromised nodes can lead to cluster-wide issues. Best practices: harden node operating systems. Example, disable unused services, apply security patches. Use node auto-scaling groups to replace unhealthy nodes. Restrict SSH access to nodes. 11th, unencrypted communication. Misconfiguration, not enabling TLS for communication between cluster components. Implications: sensitive data can be intercepted or modified in transit. Best practices: enable TLS for all internal and external communication. Use mutual TLS for service-to-service communication. Regularly rotate certificates. 12th, ignoring namespace isolation. Misconfiguration, running all workloads in the default namespace or not isolating namespaces properly. Implications: increased risk of cross-namespace interference or attacks. Best practices: use namespaces to logically separate workloads. Apply role-based access control and network policies at the namespace level. Avoid using the default namespace for production workloads. 13. Not upgrading Kubernetes. Regularly misconfiguration. Running outdated versions of Kubernetes or its components. Implications: exposure to known vulnerabilities and bugs. Best practices: regularly upgrade Kubernetes and its components to the latest stable version. Test upgrades in a non-production environment before applying them to production. 14. Improper use of service accounts. Misconfiguration, using the default service account for pods or granting excessive permissions to service accounts. Implications: compromised pods can abuse service account permissions. Best practices: create dedicated service accounts for each workload. Avoid mounting service account tokens unless necessary. Restrict service account permissions using role-based access control. 15th, lack of disaster recovery plan. Misconfiguration, not having a backup and recovery strategy for the cluster. Implications: data loss or extended downtime in case of failures. Best practices: regularly back up etcd and other critical components. Test recovery procedures to ensure they work as expected. Use tools like Valero for cluster backup and migration. Conclusion: Kubernetes misconfigurations can have severe consequences, but they can be mitigated by following security best practices and regularly auditing the cluster setup. Tools like KubeBench, KubeHunter, and KubeScape can help identify and remediate misconfigurations. Additionally, adopting a DevSecOps approach ensures that security is integrated into the entire Kubernetes lifecycle.